All right, we're going to talk about lake nutrients. So an oligotrophic lake, which is this lake right here, is going to have clear blue water. It has low levels of nutrients. Nutrients here referencing phosphorus and nitrogen, which runs off due to agriculture. And we're going to talk about what the problem is associated with this lake right here, which is obviously not clear blue. Mesotrophic, think of M for middle. It's kind of in the middle between an oligotrophic and eutrophic lake. A eutrophic lake is a lake which, as you see in this picture, is showing is losing clarity. It has an abundance of nutrients or high levels of nutrients of phosphorus and nitrogen. And cultural eutrophication leads to a hypereutrophic lake. This is us, cultural being us, causing the excessive runoff of nutrients of nitrogen and phosphorus from industrial agricultural methods, and it leads to the lake looking like this. Here's a picture of an oligotrophic lake, clear blue water, as you see. Here is meso. You're starting to see a little bit of plant growth. The water is becoming a little bit darker, nothing significant, but as you see here, algae is accumulating on the top of the water, excessive plant growth, and a lot of sediment buildup. So other threats to our marine biome, and we talked about these in class. Overfishing is one of the biggest threats to the marine biome, and these are just some pictures of overfishing. More pictures. This is factory fishing, where it still leads to overfishing, where fishermen are using state-of-the-art technology to kind of target one species of fish, and then basically that leads to a collapse in the population of that fish. This is bottom trawling. I showed you the video in class where basically they take kind of like a rake and they just scrape the bottom of the ocean, and they take everything in sight. Really, it wipes out everything in its path, including lifting up of the habitat of bottom dwellers. This is a seal trapped in a trawl net, so any kind of trap, they call that bycatch. Fish farms are a threat, and we talked about this in class as well. Although we need them to be a solution to overfishing, so they're actually a positive marine environment solution to a threat, but they also do cause damage, and I'm going to list some of the problems. Obviously, this structure here is built in the middle of the marine environment, so it's going to cause habitat destruction to the surrounding organisms. These fish tend to be overpopulated, which means they're kind of cramped, overpopulated in a confined space, I should say. So disease spreads rapidly. There also is a loss of diversity amongst the species that are farmed. They're very similar in genetic makeup, so their ability to survive external conditions become minimal. When fish do leave the farm by accident or unnaturally, they can cause damage to the surrounding areas. They're kind of become an introduced species because they don't really belong there, along with their disease that they could have acquired while being in the farm, and their lack of diverse genes causes damage to the external environments. Whaling is also another problem, and I showed you a couple of pictures about whaling. Pirate fishing. These pirate ships also basically they fish illegally. Instead of monitoring what size of fish or what type of fish they can catch at a specific time of the year, they fish whatever they want. Pollution is definitely an threat to the marine ecosystem. Direct dumping was common in the past, not so much now. But as you see, pollution can be just due to runoff or activities on land. Oil spills also can start from land and lead to the ocean, or directly through mining for oil or exploring oil. There's two types of pollution, point and non-point. Point basically is when you directly dump into a body of water. You literally would have to express that the dumping took place straight from somebody's hand straight into the body of water, or from a factory straight into the body of water. If the pollution runs off from land or has to travel through any part of the water cycle in order to get to the body of water, This would be non-point or indirect pollution. Remember, the key word here is runoff. Coastal development, big problem to the marine ecosystem. Obviously, property on the water is valuable, so a lot of construction takes place near the coast, and this is just a picture of our actual coast, Fort Lauderdale. So it leads to erosion, pollution, habitat destruction. So eutrophication, here's a picture for you to kind of embed. This is the excessive runoff of nutrients of nitrogen and phosphorus, and it leads to this algae bloom. I'm going to give you a breakdown of eutrophication now in a minute. So as I mentioned earlier, fertilizers or cleaning products are made up of excessive amounts of nitrogen and phosphorus. Due to the need to feed our overpopulated Earth, excessive farming leads to excessive runoff of nitrogen and phosphorus, and we know runoff always leads to the ocean. So this leads to algae bloom, and two things can happen once algae blooms. Sunlight will, or the ability of sunlight to penetrate throughout the whole ocean decreases. So dissolved oxygen levels will decline because there will be less photosynthesis. So photosynthesis declines, leading to less dissolved oxygen, and in turn fish die because fish need oxygen to survive. Algae bloom basically means overpopulation of algae, and once you have overpopulation of any species, that means the species is going to suffer from limited resources, so eventually the algae will die off. In order for this algae to decompose, oxygen demanding bacteria needs to break down that algae. In turn, dissolved oxygen levels will decline because this bacteria, in order to break down the algae, will suck up the oxygen in the surrounding body of water, and in the end fish die. Another threat to the marine environment is obviously climate change. Climate change leads to rising sea levels, warmer waters. When you have warmer waters, you're going to have less dissolved oxygen. It's a straight correlation. The more the temperature increase, the lower the levels of oxygen. You're also going to have melting of ice caps, which fall into the marine ecosystem. Here's just a picture. We're going to get into this topic more in detail when we do climate change. Coral bleaching is also affected by climate change. Basically, coral has a symbiotic relationship with a type of algae called, I believe, zooxanthellae. You just have to know that it's a type of algae and it's a symbiotic relationship. It gives the coral its natural color, and due to the warmer temperatures, the algae actually dies, causing the coral to lose its color and eventually die as well. Thermal pollution is basically a direct effect of electric power plants. This is a picture of a nuclear power plant. They take in cold water, like our power plant called Turkey Point is right off of between Key Biscayne and the Keys. They use cold water from the marine environment or from the ocean to help power the power plant in several ways, and we're going to talk about that when we talk about electric power plants. And then once the water travels through the power plant, it's been heated, and that heated water is thrown back into the ocean. Some power plants, which are more green, will reuse the water, but this requires them cooling the water to be able to reuse it, which requires electricity. So it's easier for them to just dump. And when they dump, this causes the dissolved oxygen levels to drop because the surrounding area becomes very warm. And as temperatures increase in a body of water, dissolved oxygen decreases. We will do freshwater threats when we cover the freshwater biome.